All right, for anybody who's playing along at home that is not here with us at school today, hey Bianca, it's okay. The room will get vacuumed tonight. Don't worry too much about that. It is all good, dear. So 611 through 614 are due. This is not 12-5. I forgot to change the date. It is 12-6. They're due today, but if you don't have them done, get them in on Monday. I've got other stuff to do this weekend anyways. So then we are on your white sheet, graphing these points. You're probably a lot further ahead than me. So if you have already graphed all the points, now multiply each of those points, x and y, by 2 and see what happens. Well, that's the question. Can you? Oh, of these points? Yeah. So, sorry, we're going to make a shape. Anybody run into issues if we multiply each of these by 2?
Can I please have Sydney Wiles to the office? Sydney?
Sorry, who said it? It's off the graph, right? Somebody said it's off the graph, right? I could multiply this by 2 and get to 4, 2. I can multiply this by 2 and get to 6, 2. But when I go to multiply these points by 2, that doesn't work. So instead, you can erase if you're mad at me and you only fit 2 points and now you're upset about it. Instead, what I want you to do for B is multiply the x points by -1. So I want you to take what you had as the x and turn it into the opposite of the x. So this point will become -2, 1. This point will be -3, 1. Does that make sense? For C, you're going to do that with the y only. The y only. And then D, you're going to do it with both. So you're going to do -x and -y. What do you mean? Oh, did you change your scale? That's why. Yeah, you can. My objective with this was to say, like, wait, crap, it doesn't fit. Because if we multiply by anything other than 1, it changes the size. Right? So what we're seeing here is the intro to dilation. If we multiply by 1, nothing changes. If we multiply the x's by -1, as somebody so astutely just pointed out, so hey, go ahead and put an A inside this shape. That we'll call shape A. And this is where you could use colors to draw your new ones. Draw shape B. Because if x's get multiplied by -1, -2 still +1. -3 still +1. Hazel?
This kind of looks like a butterfly wing pattern.
I like it. Yeah, you are right. Now when we draw C, there's one other thing that we could do. So C, only the y's multiply, so that'd be 2, -1, 3, -1, 5, -5, 2, -5. This is C. C, this is C. And then if we do it to x and y, we get -2, -1, -3, -1, -5, -5, -2, -5. So that's for D. And those No, you don't have to. That's why the start slide said you might want colored pencil. So yeah, there's like what Hazel is seeing, right? Kind of looks like butterfly wings. So, wait, hold up. Who can formalize what we just said? Like somebody said, well, that's a reflection, but there's a lot of ways that we can reflect. Simon?
So for B, you would just reflect along the vertical line?
So, for B, if the x's become the opposite, that's a reflection, and you should jot these notes somewhere, of the y-axis. Notice that when we reflect the y-axis, the y actually stays the same. When we reflect across the y-axis, the y actually stays the same. And the x becomes the opposite. This is often confusing for people. We reflected the y-axis, but the y stayed the same. So just like that, when the y becomes the opposite, what axis did we reflect there? The x-axis. Right, so that was a reflection across the x-axis. But what about D? When the x and the y are both opposite. Charlie?
I believe it is a diagonal line of 1-by-1 slope through the center.
What do you mean? You believe it's a diagonal line?
So from 0, 0, it goes to the left, up 1, left 1, and to the right, down 1, right 1.
It has are you saying that it has a slope of 1?
It has a slope of 1, 0.
Oh, so you're saying there's some line like here
Yeah.
It's basically the exact opposite.
that we could reflect across?
No.
Yes.
Oh, yeah.
Yeah, that works.
So hold on, check it though. If we did this point, I think you're on to something, but I don't know that this works here. That will work in certain situations. Patrick? It's a rotation. This A shape, our original shape, is rotated 180 degrees.
Would you put the point in the middle? Like of rotation?
That's the question. When we were on Desmos, you were rotating around like a corner of the object or a point near. So you're saying rotation. What specifically about the rotation? It's rotation. You said 180 degrees, but we need more. Ooh, it actually doesn't matter which way, because 180 degrees, you'll end up the same. But we have to say about or around the origin or the center. But we normally say origin for 0, 0. Any questions on that little discovery there? Oh, did you say origin? Sorry, you're kind of far away. Oh, my bad, dude. Origin is better than center. Not right, wrong, just better. Alright, so, no. Now, we had a question like this on our homework. Pick it up. Pick it up. I don't know what you were going to say after I, but I'm pretty sure it's I made a poor choice, and I am not using the ruler effectively, and I am off task. Because I don't think that was an accident. So, life moves on. But don't try to defend yourself when you make a poor choice. Just fix it. A dilation is the next vocab word we need to talk about. Get over it. Get your head up. A dilation is any time the size of the object gets changed. In math, we often use words like stretch or compression. So stretched means you got bigger, right? Like Stretch Armstrong, if you know that toy or whatever. Compression means we literally like squeeze it down into itself. So for dilation on your paper, please write dilation. D-I-L-A-T-I-O-N. Dilation. It's also what happens to your eyes at the eye doctor. A scale factor is how we dilate. Right? What scale factor makes us get bigger?
Anything more than 1.
Not positive.
Anything more than 1 or negative 1. Or less than negative 1.
So to stretch or get bigger, our scale factor needs to be greater than 1 or less than negative 1. Now, really, we don't actually scale with negative numbers. So we don't actually scale with negatives. What does that actually mean? Fair?
I was thinking
That negative is actually going to be some kind of flip, right? It's going to change. But guys, technically, and I need you to hear this, technically that's not a scale factor. Technically, our scale factor would just be bigger than 1, and then there would be a reflection. But if you want to do it at the same time, you just put it together and you say, oh yeah, multiply each of your points by -2, which will not only scale it, stop. We talked about helicopters way a long time ago. Put your ruler down. Having a struggle today. We talked about a long time ago. I don't even know what I was saying. So then compression, we'll just move on. What is compression then?
when you shrink it to less than 1 or less or more than negative 1.
Stop. We just talked about we don't use negatives.
Less than 1.
So compression is a scale factor.
That is less than 1.
Close.
Less than 1 but more than 0.
Yeah. Less than 1 but more than 0. Your scale factor is between 0 and 1. Questions? Yes. That is not a math question.
What do you mean by flip? Oh, never mind.
So when we just did this, right, and we like our scale factor here was 1, right? We weren't changing the size. Our scale factor was 1, but when we applied the negative, it flips across an axis. So the size stays the same, but its location moves. If this had been -2, it's not technically our scale factor because you can't scale by a negative number. If I say, hey, go outside, look at my car, scale it by -2, that doesn't make sense. But if I say double the size of it, then turn it around, we could. Or shrink it down and turn it around. Like, we could do that. You can't actually multiply a size by a negative. So by saying if we use a -2 or something like that, it's changing the size and the location at the same time. They're combining steps. It's just one of those things that you got to be really cautious. Yeah.
That means that those two are both transformations, not rigid transformations.
Did they keep the size the same?
No.
Did the size of the shape stay the same?
Oh, not that. The stretch and compression.
Yeah. Okay, well, what's on the screen right now is these.
That's rigid.
So, yeah, the stretch and compression, these are non-rigid. That's why they're called dilation. A dilation is a non-rigid transformation. Avi?
What do we have this?
Dilations.
Oh, the whole paper?
Yeah, it is multiplication and dilation, but you don't need to write multiplication and dilation. So if we multiply every point in this object by negative 2. Make a prediction for what will happen. We multiply every point, the x's and the y's, by negative 2. What would happen, Henry?
It would reflect diagonally. Across this way and not this way.
So when we multiply by negative 1,
so it would reverse across this way.
yeah, we tested like this across the diagonal on them. We're not sure that it works.
Wouldn't it just be flipping it and then stretching it?
Well, so you said we just multiply by negative x, we flip it this way.
Wouldn't it like rotate it by some amount?
So guys, reference back to the sheet we had. If we multiply by negative 1, what happened to the shape? It rotates. It flips itself around, right? Now be careful saying flip, because flip really more so means like this. So we rotate it, right? 180 degrees one of the ways. Doesn't matter which way. So this, well, the x's will flip over. The y's will flip over. And then the 2 will blow it up, right? It'll stretch it. I'm trying to move quick so that we have time for homework, but does anybody have questions on that? That the multiplying the x's by the negative, flip it over here, right? Like this point would come over here. These points would come over there. This point would come over there. Then the y's get multiplied by the negative. The whole thing flips across the x-axis. And then it expands, doubles in size. Yeah, stretches. I think we're just going to dive into homework to make sure that we have time to do that. So here's what's up. I know I stacked some stuff on you this week, and I know I'm giving homework on a Friday, which is not my normal MO. So if you don't have any of these done, which I know 614 was yesterday's homework, now, like, top priority is those. If you have those done and they're turned in, you can either work on the next home, R621, or anything you need to work on because we're near deadline. Questions on what we're doing? We have 15 minutes left.
Do you know when we'll be getting our chapter 6?
Monday. I'm almost. I'm on the back page. Just haven't been able to make it all the way through. Smells like sound effects. Oh, your chat. I was wondering what you were saying smelled like that. Yeah, those are meant to be turned in.